Phil O'Leary is from Phil Ross Consultancy, and he is going to talk about the well-documented relationship between moisture and timber, the consequences of ignoring potential hidden moisture, and the challenges and strategies learnt and developed from examining CLT of various configurations and sizes. So, Phil, welcome to the stage. Thank you.
I'm going to talk about CLT. For you that don't know what CLT is, we talk about cross-laminated timber, and these are very large panels that can be 5 to 16 meters long, would easily span this kind of area. It's became very popular, certainly before 2010 is when it started coming in, and I've worked in timber for Trada for 25 years and other things, and we inspected lots of timber buildings, and we did raise concern at the time that the CLT industry or CLT makers were saying there's so much timber there, it doesn't matter. And we did raise the question, well, it is timber and it still behaves in a certain way. And this is slightly tongue-in-cheek, but if you think about it, we've got these large panels building, we get lots of rain and we get water coming in, and we want to know what happens to that water and how it ends up, how much of it goes away, how much do we trap. And we can look at what causes moisture in CLT, and you can see there's a chap there who's actually sweeping that amount of water off. You may think that's shocking, but we have seen it a number of times. So we do ask the question, where does that surface water go? How does it get trapped? How do we get rid of it? We can also think of leaks. So we can have leaks, and we tend to put them into obviously external fabric or internal services. But very often what we really want to know is are we looking at slow leaks or what I call large events? Slow leaks often be much worse than the large events. So then we've looked at the design of things, and when we've had leaks, how does the water actually behave in these large structured timbers? Imagine that some of these panels, that they go between 90 mil thick to up to 300 mil, so it's quite a lot of timber in there. How does it behave once it gets wet, whatever the source is? And one of the big issues we've had is that with timber frame, standard timber frame, for the last, as far as I can remember, last probably 40, 50 years, we've always designed with timber 150 mil above ground level. Standard practice, but CLT, though, it's a wonder product that gets away with it. So we've seen lots of cases where CLT's been built to either at ground level or below ground level, and I know most of the time that's to do with level thresholds, but it still behaves the same way. So again, water gets trapped. So however the moisture comes in, I've pinched this diagram from the Mass Timber Institute, University of Toronto, which I think explains it quite well. I've added a 20% decay threshold there as a nominal thing, so as you probably all know, as long as we keep the timber below 20% moisture content, it won't decay. So however the moisture comes in, it's only got 3 ways of coming out, and it's quite a clever diagram. It shows you that drying by drainage is by far the most efficient and quickest way. We can then dry by ventilation or evaporation, and the really slow way is by diffusion or capillary action. So we know that we get water on timber frames, or sorry, a CLT like that, and it might not be too much of an issue if we can get rid of it quite quickly. It can evaporate if it doesn't run down walls and things. We'll see that the CLT are moving away from flat roofs and talking about putting sloping roofs. What does that causes us? Well, it runs away. Where does it run to? And here's a typical example where we've got a sloping roof, ends up with a parapet wall. And of course, we're reducing or moving away the drainage to what happens to the water when it gets into that area. And one thing we have to think about CLT is that we've got laminates that run alternate directions, and the permeability, or the way water moves along timber, obviously it moves along the grain significantly more than it does across the grain, and that's because the trees designed that to do that. And we know, for instance, that liquid water moves longitudinally between 100 to 150 times quicker than across the grain, and diffusion can be up to 10,000 times more along the grain than across the grain. And of course, we've also got glues between the laminates as well. So what does that mean? If I bring back that diagram, add in some design things, what happens is that we get that area gets wet. So the water gets wet, we get water running along the top laminates, and it tends to stay in the top laminate, and then when it hits a parapet wall or above a wall, it then gets sucked up. Yeah? And if I take moisture contents, I've seen so many surveys done CLTs where they said it's perfectly dry, people are sticking moisture meters going in only 20 mil or 40 mil, and they're saying it's 8 to 12%. But what we've got at the top there is 20% to 100% sat there quite happily, and it sits there for a long time. And I can show you plenty of examples of this. So here's a roof we've taken in, walled up, and you can see it's got soaking wet, but it's only the top laminate that's got wet and decayed. There's a kind of parapet wall where, again, the end grain has been taken up by the middle laminate there because differential takes up. So what it means is that a lot of time that when we get these water uptake, it's always hidden or very commonly hidden. And of course, if it gets wet long enough, it'll always get much more decayed. And even on the roof there on the left-hand side, you see it's limited to the top laminates. And if it stays long enough, we get this kind of scenario. When we look inside a building, here's a two sloping roofs of CLTs from two different buildings. One's got no staining, one has got staining. The right-hand one that's got staining actually wasn't decayed at all. It's simply because it happened to be above a joint and water was pouring through. So as soon as it rained, the water came through. So the end user knew it was happening, whereas on the left-hand one, we didn't. And what we had above that is that. So we just no evidence of that water at all. And the depth of it was decayed was to about the top laminate, which is normally between 25 to 40 mil thick. So here's a typical example of how we see water accumulating in a roof or on a panel. So there's the top, the left hand shows you the top where it's accumulated. And here, the right hand one shows you where we've got a junction of the walls. And typically, that's where we see water sometimes come down quite quickly, which is a good sign. But very often, the joint there, sometimes a plywood fillet or something, is totally decayed, and the timber's there's been held for quite a long time. So we see that from underneath there, and this one we might see that. So we see staining actually coming through through the joint of that. But that one there, although we can't see it, that's the condition of it. And if we go to flat roofs, we know the dangers of flat roofs. But I'm going to come back to the left-hand picture because I'm going to show you what's under that. So whether water is caused, whatever causes the moisture to be trapped, whether it's construction moisture or leaks, what we really want to know is we've got this top layer of timber that's potentially wet, and what we want to know is how long will it take to dry. Typical CLT construction, we've taken away the drainage route, we've taken away the ventilated route, and we're down to only the slow diffusion rate. So the only way it can come out is through this timber, through the whole section of the timber. So what we really want to know is how long has that been above 20% moisture content? Yeah? I've inspected dozens of roofs, CLT roofs, where the top one and sometimes the top two laminate is perfectly dry but totally decayed. It's just that it's taken that long to go from 20% to drying simply because of that mass amount of timber. So these examples are typical moisture gradients of roofs that we found. So the bottom laminate's one from the inside, the top of the roof. So we get these different gradients. So we're always worried about how long that's been wet. And if you work out how much moisture or much water is the bottom one, there's about 50 to 60 litres of water per square metre sat in that timber, extra above the 12% that we would normally expect. So when we take moisture content, it's no point sticking two probes that only go into the bottom laminate, or maybe even the third one, because that's going to tell us our roof is dry when actually it's not. So it's quite tricky. So you need to know how thick the CLT is, and you have to have a method of being able to get that, whether it's 150, 200, or even 300. And of course, often it gets hidden. So we get the right-hand one is a roof there that was detected that it was hidden by linings and things, but it was detected by someone walking on the roof thinking, wow, this roof's a bit spongy. Yeah? So this is what happens. It does happen. Here's an example of a school. This is the end of a school sport hall, the room for where they stored equipment. It's actually below that. And you can see the decay there, or the stain that has occurred from that part of the roof. The roof was really badly decayed, that's why we can start seeing it. It came back up to 2 meters away from the edge of that, with probably 50 to 60% decayed. The wall, the back of the wall, you can't see it, but over 50% of that is missing through decayed. But the biggest worry was what's at the bottom, where the water's run down, and the bottom along the whole long for about 8 metres, the bottom 200 mil was totally decayed, simply because the water's run down. We can't see it, it doesn't look stained, but it's been wet for an awful long time. I haven't got the picture of that inside, but here's another example of this is what we could see. This is another school. We could see from the inside, timber looked perfectly okay, but on the outside, when we took the cladding off, totally decayed. We're able to drill through these walls with decayed texturing methods, and we found that surprising to the construction company at the time, that they didn't believe us when we said originally that you've got at least half the wall missing at the back. We made them take the cladding off just to show that's what happens. And the one we see more and more, and we're hoping to get away more, is this where we got the bases of timbers below ground level. We've taken off the skirtings there to show you that it's totally decayed. We can't see it. What typically happens is that it gets built like this. Yes, contractors will put membranes around it, but water obviously just sits there, and then it's hidden, and it just stays there for as long as needs be, because no one knows it, and it's got no route to dry out. So that's a big issue all the time, is how do we deal with this trapped water? So here's a typical example. The left-hand side and the right-hand side are the same floor, but you can see how that metal flashing or skirting is hiding the decayed timber. And that's been wet like that for probably 2 or 3 years. And the whole of the wall's decayed. What's the consequences? Is that we have to repair it. But we also have issues where just small leaks or slow leaks, and this again, typically, we've got floors. We've got floor slab that could be 150 mil to 250 mil depth. It leaks on the top, it's totally hidden by everything. Because of that thickness, it just stays wet there for years, potentially years. And it's only when people start thinking, ooh, this floor's a bit spongy, that we start investigating. You know? So those decayed walls, what we've had to do is basically take that decayed timber out. This is one method to do it. There are various methods to do it. And we use resin bonded methods there to prop the wall up, to get it above the 150 mil above ground. There they put it about 200 plus. And we end up with that kind of scenario designed correctly. The industry is moving more towards that because of the potential consequences. It's taken a lot of time for them to understand that timber still behaves the same, whether it's mass timber or timber frame. I'm not going to talk about these things, but there are now people who've moved to protective coverings. Here's an example there, covering to protect that water. Where do we get to? Does it get damaged on site? Quite often it does. We're now looking at how we roof things, how we tent things. Do we tent parts of it? On the continent, you'll see them where they build whole buildings under tents. Huge cost, but it saves a lot of things. We're looking at the benefits of tapes and other moisture barriers, end grain sealers and coatings. There's a whole raft of things going on. We'll see, I'll come to moisture management plan shortly, where they talk about drainage holes. So when you've got a roof, can we have large drainage holes to get water away? And we've been trying to get, one of the advantages of CLT from an architect's point of view is I can design any kind of fancy, intricate thing, but the more times we have intricate buildings and intricate things, we end up with much more water traps. So we're trying to get away from that as well. But what that's meaning, what's happened over the last 3 years, the left-hand one I did put on as my charter days. We did a 2-year project looking at how timber behaves, or CLT behaves. How it wets up, how difficult it's wet up, how difficult it's to dry, what happens if we add heat to it, what happens if we put one side cold, one side hot, what happens to the moisture, and all that kind of stuff. So the STA, Structural Timber Associations, now have documents that show you how to best to design, and they will tell you, get the timber in walls at 150 mil above, to the whole raft of American ones that go. It's quite... And because of now they've recognised that this moisture is an issue, primarily sort of driven by insurance companies and by warranty providers asking questions. So now we've got these what we call moisture management plans. They're quite generic. They tend to tell you what you need to do, but they don't tell you how to do it, which is obviously the tricky bit. And there's a whole region from the STA to the UK. 2 American ones, and 2 even Swedish would have got one. So it's been moving forward. There's a very good document that's just been, actually it came out in July. I think it's downloadable for free. Moisture management for timber construction. It explains very well about the risk, how this happens, and the role of protective coatings and all that kind of stuff. And it's got to the point where insurance companies are now actually producing their own things. That's how concerned they were, and it's been a big issue for CLT, is how do we get insured? So you've got the Mass Timber Insurance Playbook, done by SPB, and so and the insurance involves, again, they're looking at how do we protect timbers, and you've got even Aviva who's got their own document about how to protect moisture, because it becomes such a big issue for these big buildings, and it's all to do with, we get wet, how does it behave, and how do we get rid of it or protect it? So what's happening now, and it's part of the insurance industry, I've taken this from a company called Tector, but I did speak to someone, I don't know if they're here, there's another company called Vector who do exactly the same thing. They're the 2 biggest companies that do moisture monitoring, and it's becoming a much bigger thing. And then the insurance industry, I think, are going to push CLT or mass timber down this route because they want data. And what we want to be able to realise that during the construction process, but more importantly after the construction process, is can we have an early warning system that we're getting wet? We can't see it, but we want to know it's wet. So it gives stakeholders, whether it's council, schools, homeowners, instantly, you get texts and all sorts of things. It shows you what it is, and it reduces the potential costs by 95% or plus. I've done this whole bunch of surveys for a county council that's got 8 or 9 schools built with this, and they've got problems in 6 of them. So the cost of them is horrendous in terms of repairing. How does it work? Well, we put sensors in different places. It will depend on what the building is and where it is. But it records data. The top one is an experiment that was done with just a piece of timber that we wetted up, and then it's brought into an environment where the dotted line gives it equilibrium moisture content of around 12-14%, and you can see it came down quite quickly, and the monitors matches it very quite well. It also measures temperature and humidity. And here's a real case scenario where you can see the top diagram. There's been a big spike where the timber's got up to 20% moisture content, and then the leak's been stopped. But can you see how long it takes for it to come down, anywhere down below to 20%? It takes months and months and months. That's even after we've stopped the leak. So these are becoming much more important, and I think the insurance companies the insurance companies will definitely push more towards this, particularly for CLT, and the CLT industry is probably going to have no choice but to do that for getting insurances. So just to conclude, we know how water gets into CLT, we know how it travels, we know the difficulties of identifying it. This is where monitoring is going to become much more, obviously. We know how difficult it is to dry, the long time frames, and we also know how expensive and the challenges in repairs, because it's not easy repairing CLT. If you go to CLT manufacturers and say, how do I repair this? They'll say, go and consult a structural engineer. Yeah. So with this knowledge, we can do it, but it still relies on people during the construction process. How do they monitor it? How do they stop it getting wet? How do they take moisture contents? Are they capable of taking moisture contents in the right way? Because we've seen so many reports of damp reports, if you like, or moisture content reports of these large structures, which are totally ineffective and totally incorrect. So really, that's part of the issue: is how do we train people to actually take moisture contents in these places, and what does it actually mean? So that's